All right, I'm going to talk about the amino acid leucine. So here's the table of amino acids from the Wikipedia page for amino acids. And I've sorted it by abundance in proteins by percent. So, roughly 10% of proteins, taking pretty much every protein you can think of into account, 10% is going to be leucine. So I think it's helpful just to draw it. Any amino acid, sorry, is going to have this alpha carbon, your amino group, and your carboxylic acid group. So I'm going to just draw them uncharged, even though in a cell they would be charged on the sides here. So this is your starting point for any amino acid. The side chain for leucine is going to have a carbon followed by a second carbon, which branches out into two carbons. And those will all have saturated with hydrogens. Oops. I was just trying to do that. So I've already searched for it, so here it is on the right side. So organize it with the N terminus on the left and the C terminus on the right, with the hydrogen projecting to the distance and into the background, and the side chain coming out into the foreground, since it's the left-handed version. You can kind of see, I'm assuming this is correct, or how it would actually physically be oriented, but it kind of leans off towards the side, back towards the C terminus. Just to see how they draw it, here's your alpha amino acid and your side chain here of the hydrocarbon branch, if you want to call it that. Here's the Wikipedia page for leucine. I guess I don't really have anything to say about it on this page. So it is a branched chain amino acid, meaning that the side chain is a branched hydrocarbon chain that does not have any cyclic loops in it. So it's kind of grouped into a category with isoleucine and valine, which share that characteristic. So yeah, it is uncharged hydrophobic side chain. The name leucine actually is a Greek word for white. In modern Greek, it's still similar. It's actually lefko is how you pronounce it in Greek, but if you kind of convert that into English, the K's or the kappa usually ends up as a C and ends up with more of an S sound. So even though it's lefko in Greek, it's leucine, pronounced in English. And it is a white powder. If you search for leucine powder, you'll see a bunch of supplements, but any picture of the actual powder is just a white powder. It is an essential amino acid, so it's something that your body, essential in humans. I guess that's a good point, is when we say essential, like essential to what organism? And most of the time it's humans, but you might need to point that out, that it's essential amino acid in humans, meaning that we can't make it from other components. We need to have it as an ingredient in our diets. I think that's everything I was going to say about it. Okay.